Hello, everyone. My name is Mr. Bryce. I'm with Susquehanna Valley High School here in Conco, New York. My email address is rbryce@svsavers.org if you want to contact me. We're doing the Algebra 1 Common Core Regents from January 2016, the actual questions that they gave. Now here, we're now on number 25, which is the first of the part 2 questions. They will receive 2 credits each. Clearly indicate all necessary steps, including appropriate formula substitutions, diagrams, graphs, and charts, etc. Utilize the information provided for each question to determine your answer. Note that diagrams are not necessarily drawn to scale. They're not drawn to scale. For all questions, this part, a correct numerical answer with no work shown will receive only 1 credit. Great! No work, right answer, 1 point out of 2. All answers should be written in pen except for graphs and drawings, which should be done in pencil. Okay, ladies and gentlemen, and you will know that during the test I will tell you to go ahead, write them in pencil, and then copy them over in pen. Why do I have that done? Because things outside the graph have to be in pen. Okay, so why not just, instead trying to determine which part is the graph and which part is not the graph, just do everything in pencil for the graphing question and then trace over it in pen. Number 25, the function t of x is shown in the table below. There it is. Determine whether t is a linear or exponential equation. Doesn't say equation, a function, let's just say. Explain your answer. Okay, there are 2 ways to do this question. My goal is to have you get 15 of the multiple choice questions right and 1 point on each of these open response questions. That's the goal. Of course, we'd love to get 100. That's our minimum goal. So we're going to do these 2 different ways. Let's take a look at the calculator. It wants to know if it's a linear or exponential. So to find the equation of the line, what I did was I hit Stat, Edit, I entered the data, then I hit the Stat key, Calculate, and let's go to a linear regression, which is choice 4. Some of the times you have to hit enter several times, like I'll show you on the other calculator, and other times you only have to hit it once. Now remember, the diagnostics are turned on when we're doing a linear regression. So here we see that R is -1. That is a perfect fit. When R is 1 and -1, it's a perfect fit. All of the points line up into that form of the equation. So I entered it there, and it asked us also if it was exponential. So again, we enter in the data, it's already there. Instead of doing the calc for linear, we go all the way down to choice 0, which is exponential. We have to calculate, and it gives us here a domain error. What does that mean? That means that, remember, XY domain range. Now, even though it said a domain error, it's really a range error because it doesn't have any such thing as a domain error. So we have a problem here with the exponential equation. It won't even calculate an equation for us, won't calculate the function. So I would write here that it is a linear because R equals -1 and exponential gives a domain error. Now, before submitting to the fact that it is a domain error, you will check your data twice to make sure that the data is typed in correctly, in the correct manner. I told you there were 2 ways to do this. We're going to take a look at delta y over delta x. Delta y over delta x. These are for lines. Remember, linear equations, linear functions, delta y, the rate of change. Now, we're going to look at for the rate of change, not the average rate of change, the actual rate of change. Here, the delta x is +2. Here, it is -2.5. Here, it's +2. Here, it's -2.5. Here, it's +2. There, it's -2.5. The delta y is just the change. I did -1 minus -3 over 7.5 minus 10. So that is 2 over -2.5. And I kept on doing that for all of those mentally. So we find out that it has a constant. Here's the second answer. A constant delta y over delta x. So it is linear. The next question, question number 26. Marcel claims that the graph below represents a function. State whether Marcel is correct. Justify your answer. If you say he's right or wrong, you're not going to get any points. So there are two things that we see with this. Claims that the graph below represents a function. So this is a yes answer. Yes, this is a function. No, it is not a function. No, it is not a function. Okay, why is it not a function? What is the definition of a function? The definition of function is every x has only one y, or for every x there's only one y, for every input there's only one output. But for x equaling 2, it goes to +3 and -1. If you draw that on your test paper, that is fantastic. Okay, there's another reason. Also, it fails the vertical line test. As a reminder, the vertical line test, you take your ruler and you run it along the graph vertically. And if it touches the graph right there, two places at the same time, it fails. Now, draw this over here. If the graph looked like this, with an open circle, and then had a closed circle down there and went up, that passes. This fails, because remember, an open circle is not included. Okay, if you have any questions, make sure you ask me in class on this. Let's go on to the next problem. Solve the equation for y. That's a literal equation. We want to get y by itself. What you notice is, y is in two different places. So we're going to have to, first of all, distribute. Y minus 3 times y minus 3. That square says write it down twice. So this part of it, y times y is y squared. Y times -3 is -3y minus another 3y plus 9. Combining like terms, we have y squared minus 6y plus 9 equals 4y minus 12. If you don't understand the rainbow method, we can use the area model. And you put y minus 3 and y minus 3. Y times -3 goes in there. negative 3y. Y times y goes in here, y squared. Negative 3 times negative 3 goes in there, which is positive 9. Negative 3 times y, negative 3 times y, negative 3y. And then we can combine our like terms to get negative 6y, our y squared, and our 9. I brought down the 4y minus 12 here. So we have to solve for y. Now, that means get all the y's on one side, no, not everything else on the other, because this is going to turn out to be something with an exponent of 2. So I'm going to subtract the 4y, y squared minus 10y, yes, negative 6 minus 4 is negative 10, plus 9 equals negative 12. Now we may want to complete the square here, but let's check it out first. Y squared minus 10y plus 21 equals 0. What do I mean? Check it out first. Let's get out our graphing calculator. Now, what in the world is going on here, Mr. Bryce? You put in an x wherever there's supposed to be a y. Well, remember, the variable key shows up for an x. Doesn't matter if it's an x or a y. This doesn't say, we're looking for it to equal a specific number. We're looking for it to equal the zeros. And it graphed it for us right here. So let's hit the graph key. And there's the graph. Now what I am looking for is I'm looking for the fact that it crosses at integers. It crosses at positive and negative whole numbers plus 0. So look at the table. It looks like it's 3 and 7. And we do see that in fact it is 3 is a 0 and 7 is a 0 on our table. So this factors, and we know for a fact that y is going to equal 3 and that y is going to equal 7 from the graph. And I said that it factors. So y equals 3. If we subtract 3 from both sides, we get y minus 3 equals 0. So y minus 3 equals 0. Same is true for y minus y equaling 7. You subtract 7 from both sides, so y minus 7 equals 0. So y minus 7 equals 0. Now the product, either one of these has to be 0. Y minus 3 times y minus 7, the product has to be 0. So there are our solutions. Y equals 3 and y equals 7. We solved it algebraically. I cannot emphasize enough that on every single one of these questions, we want something written down. We want to get at least 1 point on all of these free response questions. If you have any questions for me, make sure you ask me in class. I'll see you later, guys.